Usually angles we mark in degrees 0, 10, 20, 30, 90, 180, 270 back to 360. This year we are going to learn a new measurement for angle called radian. Not radius, it is radian. What is 1 radian? If I consider the radius of the circle is arc, this is also radius of the circle, say arc. Consider an arc of length equal to r. So this and this are equal. The arc length r subtends an angle at the center. So that angle we define as radian. To put it in proper words, 1 radian is the angle subtended by an arc of length equal to the radius at the center. So that we call radian. Suppose radius is 1 unit. What is the entire circumference? 2 pi r. The 2 pi r, the entire circumference, what angle is equal to? 0, 90, 180, 270, 360. 2 pi r is 360. We are taking radius to be 1 unit. So 2 pi radians is 360 degrees. And therefore, pi radians will be 360 by 2, 180 degrees. So we must know to convert degree into radians, radians into degrees. So pi radians 180 degrees tell me 1 radian is 180 degrees by pi. We know pi value is 22 by 7. You substitute 22 by 7. If you divide, we get 1 radian is 57 degrees, 17 minutes, 45 seconds. These are subunits for the degree. 1 radian equals 57 degrees, 17 minutes, 45 seconds. What does 1 minute mean? Single line that we put, we read it as 1 minute, and 1 minute is nothing but 60 seconds. Instead of seconds, we put double line here. So I read it as seconds. 1 degree, or in other words, I say 1 degree equal to 60 minutes. Single line tells me minutes. So 1 degree I call 60 minutes, whereas 1 minute I call 60 seconds. How to convert our usual angles that we know? Pi radians 180 degrees. Then what about 90? If I divide by 2, 180 by 2 is 90. So pi I divide by 2. 90 degrees is nothing but pi by 2 radians. 45. How do I get 45? Half of 90 is 45. So pi by 2, again you divide by 2, I get pi by 4 radians. How about 30 degrees? 180 divide by 6, I get 30. So 180 by 6, pi by 6. So 30 degrees we call pi by 6 radians. 60 degrees. How do I get 60 from here? 180 by 3. So 180 by 3 gives me 60. 180 is pi. So pi by 3 radians. Let us remember, hereafter we do not refer to degrees. In all the problems we come across radians. So whenever 90 comes, read it as pi by 2, or pi by 2 comes, understand it as 90. Similarly, 30 is pi by 6, pi by 6 is 30 degrees. 60 degrees is pi by 3 and pi by 3 is 60 degrees. 45 degrees is pi by 4 and pi by 4 is 45 degrees. Exercise 3.2, question number 1. Express each angle in radian measure. 30 degrees. Let us remember the formula. 180 degrees is pi radians. Therefore, 30 degrees is 30 into pi by 180. Cancel, it is pi by 6 radians. The second question, 135 degrees. 135 into pi by 180. Cancel with 15 table. 9 15s are 1, 2, 9 by 12. Again I can cancel 3 table. It is 3 pi by 4 radians. 135 degrees is equal to 3 pi by 4 radians. Minus 205 degrees. Minus 205 tells me we measure in clockwise. Conversion, it is the same. Pi by 180. Cancel with 5 table. It is minus 41 pi by 36 radians. 150 degrees. 150 into pi by 180. Cancel with 5 table. 5 pi by 6 radians is my answer. 330 degrees. 330 into pi by 180. Cancel 0 and then 3 table. 11 pi by 6 radians, and that is the answer. Question number 2. Express each of the radian measures in degrees. Subsection 1, pi by 3. Let us remember pi radians equals 180 degrees. So pi by 3 will be pi by 3 into 180 by pi. Cancel pi and pi. 3 in 180, 60 degrees. Pi by 9. Pi by 9 into 180 by pi. Pi pi cancel. 9 in 180, 20 degrees. 2 pi by 5. 2 pi by 5 into 180 by pi. Pi pi cancel. 5 here 36 times. 2 into 36, 72 degrees. 7 pi by 3 into 180 by pi. Pi pi cancel. 3 60 times. 7 into 60, 420 degrees. 10 pi by 9. 10 pi by 9 into 180 by pi. Again pi pi cancel. 20 times. 20 into 10, 200 degrees. A very simple conversion from radian to degrees. Multiply by 180 by pi and simplify the answer. Question number 3. What must be the radius of a circular running path around which an athlete must run 5 times in order to describe 1 kilometer? One circle tells me the circumference is covered. The circumference of the circle is 2 pi r. So one time to run he covers 2 pi r distance. If he is running 5 times, 5 into 2 pi r, 10 pi r. 10 pi r is covered to describe 1 kilometer. Because it is given 5 times is 1 kilometer. 10 pi r is 1 kilometer, or write it as 1000 meter. Therefore, 10 into 22 by 7 into r is 1000, or r is equal to 1000 into 7 by 22 into 1 by 10. Cancel and find out the answer, 31.82 meter. Hence, radius r equals 31.82 meters. Question number 4. In a circle of diameter 40 centimeter, a chord is of length 20 centimeter. Find the length of the minor arc of the chord. Diameter 40 tells me radius of the circle is 20. Chord length is given to be 20. Let us mark a chord AB which is 20. Chord is a line joining 2 points on the circumference. OA is the radius, OB is the radius, AB. So what I understand from here, OA equals AB equals OB because every measure is 20. Therefore, OAB becomes an equilateral triangle. Whenever it is an equilateral triangle, all the three angles are 16. The very important idea, equilateral triangle, all angles are equal. Three angles together 180 or each angle is 16. So I will say angle AOB, it is 60 degrees. 60 degrees if I convert into radians, remember it is pi by 3 radians. Once I know angle at the center in radians, I can find out the minor arc. We have AB the chord, this I call major arc and this I call minor arc. This minor arc is subtending an angle 16 or in radians pi by 3. So what is the minor arc? The length of the minor arc is r into theta. Theta should be in radians. What is r? 20. What is theta? Pi by 3. Simplify 20 by 3 into pi value 22 by 7. 20.95 centimeter. So length of minor arc is 20.95 centimeter. Question number 5. Find the degree measure of the angle subtended at the center of circle of radius 100 centimeter by an arc of length 22 centimeter. Radius of the circle is 100. The arc length is 22. We know the formula. Arc length is r into theta. R is 100. Theta is in radians. But the question is find in degree measure. Theta equal to 22 by 100 into, how to convert radians into degrees? It is 180 by pi. We know pi radians equals to 180 degrees. Therefore, this many radians equal to 22 by 100 into 180 by pi. 22 by 100 into 180 by 22 by 7. Cancel. Simplify the answer. 180 by 100 into 7. We get 1.8 into 7. 1.8 into 7 is 12.6 degrees. Otherwise, we can write 12 degrees. We know 1 degree is 60 minutes. Therefore, 0.6 degrees can be written as 0.6 into 60, that is 36 minutes. So, either I can say 12.6 degrees or 12 degrees 36 minutes is my answer. Question number 6. What is the length of arc intercepted by a central angle of measure 41 degrees in a circle of radius 10 feet? Radius is given as 10. Arc length is the question. What is arc length formula? R into theta. Remember, theta should be in radians. In this question, theta is given as degrees. Let us remember 180 degrees equal to pi radians or 41 degrees is equal to 41 into pi by 180. So this is 41 pi by 180. Substitute r equals 10. Theta value 41 pi by 180. Simplify this answer. We get 451 by 63, which is 7.16 feet. Question number 7. If in two circles arcs of the same length subtend angles 60 degrees and 75 degrees at the center, find the ratio of their radii. Theta 1 60 degrees, theta 2 75 degrees. Degrees let us convert into radians to find the arc length. 60 into pi by 180, pi by 3 radians. 75 into pi by 180, 5 pi by 12 radians. Given arcs of the same length, that is R1, R theta is the formula. For the first circle R1 theta 1 and for the second R2 theta 2. They are equal. The question is ratio of their radii. So R1 by R2 equals theta 2 by theta 1. R1 by R2 equals theta 2 is 5 pi by 12 divided by pi by 3. Reciprocating 5 pi by 12 into 3 by pi. Cancel and we get 5 by 4. So take and write the ratio. R1 is to R2 is 5 is to 4 and that is the answer. Question number 8. The perimeter of a certain sector of a circle is equal to the length of arc of a semicircle having the same radius. Express the angle of the sector in degrees, minutes and seconds. Consider this angle to be theta. The radius let us take r. For the semicircle as well as for the sector it is same radius. The arc length we call r theta. The very first line is perimeter of the sector. The word perimeter tells me add all the sides. So r theta. I get r plus r theta. It is 2r plus r theta. If r I take common, it is r into 2 plus theta. Length of arc of semicircle. Full circle is 2 pi r. Semicircle will be pi r. So the length of arc of semicircle we get pi r. Given both are equal. So let us compare. This we call 1 and this we call 2. 1 equals to 2 implies r into 2 plus theta is pi r. Cancelling r. 2 plus theta is pi or theta equals pi minus 2 radians. What is the question? We want to express it in degrees, minutes and seconds. So, let us remember the formula. Pi radians is 180 degrees. Therefore, pi minus 2 radians. Let us convert pi minus 2 into 180 by pi. We'll simplify the answer. 22 minus 14 by 7. 180 by 22 by 7 reciprocate. It is 7 by 22. 7 and 7 we can cancel. 22 and 180. By 2 table we can cancel 11 and this is 90. As I simplify, 22 minus 14, 8 into 90 by 11, that is 720 by 11. 720 by 11 we divide and show. 65 is the quotient. 5 by 11. So we write 65 5 by 11 degrees. 65 degrees retain as it is. 5 by 11 being a fraction, multiply by 60 minutes. 5 into 60, 300 by 11 as we divide. I get 27 3 by 11. 65 degrees, 27 3 by 11 minutes. 65 degrees write as it is. 27 minutes being the whole number, keep it. 3 by 11 minutes. Multiply by 60 seconds. 3 into 60, 180. 180 when I divide by 11, I get 16. So, my final answer is 65 degrees, 27 minutes, 16 seconds. So, the given question, converting radians into degrees, we have learnt a new process. When I get 720 by 11, 720 I divide by 11, the whole number I keep as degrees. The remainder 5 by 11 degree, but it is a fraction. So multiply by minutes. 1 degree is 60 minutes. So 5 by 11 when I multiply by 60 minutes, I get 300. When I divide by 11, 27 minutes I retain. The remainder 3 by 11 I have as a fraction. This 3 by 11 multiply, the next subunit is seconds, 60 seconds. 3 into 60, 180, which we have divided. The quotient 16 tells me it is 16 seconds. So we combine the 3. 65 degrees, 27 minutes, 16 seconds. That is the final answer in degrees, minutes and seconds for the given radians pi minus 2. Question number 9. An airplane propeller rotates 1000 times per minute. Find the number of degrees that a point on the edge of the propeller will rotate in 1 second. Here the unit is minute, whereas here the unit is second. Let us convert. In 1 minute it is rotating 1000. So, in 1 second, 1 minute is 60 seconds. In 60 seconds, it is rotating 1000 tells me in 1 second, 1000 by 60 rotations. 1 rotation tells me it is covering 360 degrees. Therefore, in this many rotations, these two together tell me multiply. 1000 by 60 is number of rotations into in 1 rotation 360 degree. If I simplify, it is 6000 degrees. So, a point on the edge of the propeller is rotating 6000 degrees in 1 second. Word problems. Try to write the answer in statement. So, number of degrees rotated in 1 second is 6000. Question number 10. A train is moving on a circular track of 1500 meter radius at the rate of 66 kilometers per hour. What angle will turn in 20 seconds? Circular track. So, if this is a circular track, the train moves tells me it is the arc length. So, what is the arc length? R theta. R is 1500 theta. That arc length, how to calculate? We go with the speed of it. What is the speed? 66 kilometer per hour. What does this mean? 66 kilometers it is covering in 1 hour. But my question is based on meters and seconds. Convert 66 kilometers per hour into meters per seconds. How to convert? Multiply by 5 by 18. 66 into 5 by 18. Cancel with 6 table, 11 by 3 or 55 by 3 meters per second. Now what does this mean? The train covers 55 by 3 meters in 1 second. So distance covered in 1 second is 55 by 3. But my question is in 20 seconds. So 55 by 3 multiply by 20. Now this is nothing but the arc length. So 55 by 3 into 20. In 20 seconds, the distance covered is nothing but the arc length. But arc length, we already know the formula r theta, that is 1500 theta. So 1500 theta is 55 by 3 into 20. Therefore, theta equals 55 by 3 into 20 divided by 1500. 0, 0 cancels, 5 table 30 times, 5 table 11 times, 2 into 11, 22 by 90, this is theta in radians. To give it in degrees, theta equal to 22 by 90 into 180 by pi, that is 22 by 90 into 180 by 22 by 7. Cancel, reciprocate 2 into 7, or we get theta is 14 degrees, and that is the required answer. Question number 11. A circular metallic plate of radius 8 cm and thickness 6 mm is melted and molded into a pipe. A pipe is in the shape of a sector of a circle with some thickness. Radius is 16 cm and the thickness is 4 mm. Find the angle of the sector. Let us remember one particular solid melted and molded into another. That tells me volume of the first one and volume of the second one must be equal. How to find volume? Volume of any solid shape, we can say area into thickness. First one is circle, second one is sector. Circle, we have radius is 8 cm. So area is pi r square. 8 square, 64 pi. Thickness is given as 6 mm. Each one cannot be of 1 unit. Convert. 6 mm is 6 by 10 centimeter. What is the volume? Area into thickness. So circular metallic plate, we found out the volume. The next idea, the pipe which is in the shape of a sector. Again, what is radius of the pipe? 16 centimeter. Area of the sector is r square theta by 2. R is 16, 16 square by 2 into theta. 256 theta by 2. As I cancel, it is 128 theta. Thickness of the pipe is 4 millimeter. Change the unit into centimeter, so it is 4 by 10 centimeter. What is the volume again? Area into thickness. Area 128 theta into thickness is 4 by 10. Since it is given melted and molded, both the volumes are equal. Compare 128 theta 4 by 10 equals 64 pi 6 by 10. As we cancel, theta equals, we can cancel 10 and 10. 64 here 2 times, 2 here 3 times. So I am left with 3 pi by 4 radians. Remember, in sector area, we say theta in radians. Or otherwise I can say it is 135 degrees. So either in radians or in degrees you can give the answer.